Hi everybody. So we've installed Windows. We have installed updates, drivers. Now we're going to install some tools to test the stability of our system and to some tools that will provide some information. So here are some basic tools. Let's start with google.com. Let's start with CPU-Z. Uh, Download this tool. Then we can get GPU-Z. Google.com. GPU-Z. Let's grab that. Let's see, where is this? There we go. We have that one. Now, what else do we need? We can have HWInfo. Next, we're going to need Prime 95. Grab this one. Next, we need a tool called Rufus. This thing. Then we need memtest 86. Download. And I believe that is good enough for the time being. So we have CPU-Z, GPU-Z, HWInfo, Prime 95, Rufus, memtest. Oh, we're missing a couple of things. Let's go. FurMark. We're gonna need this thing. And one more thing. If you have AMD system that supports it, we can grab RyzenMaster. Right. For some reason, FurMark was blocked because it could harm your device by the Windows Defender, but I think it's a false positive, so we're going to keep that. Microsoft Defense Smart Screen reported that this app is not commonly downloaded. I see. Show more options, keep anyway. So we want to keep our FurMark. And so this is what we have. So we are going to be using a USB drive with nothing important on it. So if you have a USB drive that has any important data on it, move it over, back it up somewhere, and make sure that there's nothing there that you don't want to lose. Now let's go ahead and install our tools. So first thing we want, we can go ahead and install CPU-Z. GPU-Z, I believe, is a standalone application. There is no installer. So HWInfo installer. I don't want to launch it right now, so I'll just finish that. Prime 95 does not get installed, so we can just extract it. Extract it there, and it's right there in the current directory we extracted it into. Rufus is a bootable USB drive maker app that will help us make our memtest 86 USB flash drive, so we can extract the memtest, and I believe memtest already comes with a USB maker utility. So, and if that's the case, Rufus is optional. You don't need that. Let's go ahead and install FurMark. More info, run anyway. Yes, let's install FurMark. Next, next. Let's create a shortcut. Next, install. Free image error has occurred. Geekbench. Benchmark FurMark free image. Why is this giving us a problem? I think we are having an issue with our antivirus reporting this as a false positive. So let's see what we can do about this. This has not happened to me before when installing FurMark, but anything is possible. So let's cancel installation. Let's see. Let's try FurMark again. The source file is corrupt. Cancel installation. Let's try this again. Google.com, FurMark. This thing, and this version might have a problem, so we'll just grab the previous version just in case, so we would not need to worry about trying to resolve an issue that may be just a bug in the installer or something. So okay, FurMark previous version. Let's go ahead and try to install that. That works. Perfect. We're not going to launch that right now. And for our last utility, we are going to run the RyzenMaster installer. And it's going to install a Visual C++ library. Agree, install. Very convenient. I agree. Oh, it wants you to read the license agreement before you click I agree. Warning, this is pretty much warning you about overclocking. That you do this at your own risk and it's possible to damage hardware. We're not going to be overclocking, we just want this to monitor our CPU. At least we're not going to be overclocking in this video. Exit the installer. So we have everything we need. What we want to do. Let's go ahead and launch RyzenMaster. Warning, and this is giving us another warning about overclocking. So we're not going to go over to advanced motor settings. We're just pretty much we want to see our temperature, and everything else is default. So we can put this thing in the corner. Let's see, next. To test the CPU, what we want to do is launch this Prime 95, and we're not joining GIMPs, we're just stress testing. Blend all of the above, and we are good to go. So it's going to open up a window inside here for each thread that the CPU is capable of. So it's not really feasible to see everything because I guess you could just look at them one at a time. Here's what, for example, worker 1 is doing. So we're running the stress test. We can go ahead and put this aside and see what our CPU is doing. So right now we're running at 4.2 gigahertz all cores, and our temperature is 55 degrees Celsius. This is fine. So what we want to do is, well, it depends on how much you want to see if what your system is capable of. I usually run this test on new systems for about 8 hours minimum. Uh, at full speed, you would want to probably watch this for the first like 15 minutes or so to make sure the temperature is okay. It will throttle itself if the temperature goes higher than it should, so it will, it should not, if you did not explicitly disable the built-in protections, should not um, cause any damage to your system. But please be mindful that this is not the absolute most stressful thing that you can do to your CPU, but it is high up there in terms of intensity and the workload and stress on your CPU and memory. So while that's running, we could launch FurMark. Now uh, this GPU is a joke. It's Radeon 5450, and it is, I'm not even sure if FurMark will run on it. But the FurMark does not appear to be launching. It could be, I usually have no problem with launching FurMark while Prime 95 is running, but since the CPU load, let me just illustrate it here. If we open up Task Manager and we look at our performance, and we see 99% of our memory is utilized and 100% of our CPU is utilized. And if we go to over here, change graph to logical cores, logical processors, we see that we are at maximum load. Uh, oh, there it goes. So it took a little while to launch. So we have our CPU test running. We have our temperature, which is good. And we could, here, we could launch our GPU stress test. You can do full screen. You have some options here, but to illustrate this, we can just launch it as is. It gives you a warning that it is very intensive. It will stress your GPU and VRMs, and it gives you possible causes of instability, too high of an overclock, insufficient power supply, problems with the VGA cooler. So you can have power problems, you can have setting problems, or you can have cooling problems. So on a system that has default settings, if you did not tweak any settings and you have adequate cooling, this should run with no problems at all. So, of course, this GPU is very, very slow. So it looks like a slideshow for this particular GPU, but it's still running and it's still stress testing it, and this GPU is passively cooled. So we could actually see, I believe, the temperature of the GPU core here, right there. We can also see our temperatures in another. Oh, it gives you temperatures right here, your GPU temperatures. So this is running, that's running. Running this test for about 8 hours, both of these tests. I should give you a good idea if your system is stable or not. If you want to do overkill, you can run it for 24 hours. If nothing happens in 24 hours, uh, your system is stable. Just bear in mind, you do this at your own risk because each system is different. Laptop systems are more prone to stress during high load and cooling. You also should be mindful that any dust or obstructions of your heat sinks will affect your cooling performance negatively. So the heat sinks should be cleaned. Um, the fans should not be obstructed. So so you get the best out of your cooling. Now, so so this. What else do we have here? We have CPU Z. CPU Z. Let me just go ahead and pull this down. We're gonna go ahead and launch this. Sorry about that. So, what do we have here? Is everything okay? Yep, everything's fine here. Now, our CPU Z gives us information regarding our CPU motherboard memory. So here we have our memory information, our motherboard information, which BIOS version we're running, the date when the BIOS was released, memory information. A 64 gigabytes DDR4. So that's 1800 multiplied by 2. That's our 3600 megahertz effective speed. Command rate is 1T, and the timings. Very good. And yep, everything's good. Our XMP profile is enabled, as we saw over here. There it is. So we have our GPU information here also. So there, that's pretty much all that tool is useful for now. We have GPU-Z here. What would you like to install? Yeah, why not? Let's install GPU-Z. And we can launch it. It'll give us the information about our GPU. So we're at 70 degrees. Memory usage. Driver information. Hmm. 11-year-old GPU. Okay, that's cool. So, and that last tool that, well, not the last tool, but we have this hardware info that we've also installed. We can go ahead and run that. And it'll give us hardware and sensor information. So let's run it. A very comprehensive tool. Could also be used to monitor. So what do we have here? So currently we are running at 3.8. So we did throttle a little bit after running at maximum load for a while, which is normal. Voltage went down a little bit once we reached 70 degrees, which is fine. Let's see. Okay, so we have sensors. It'll give us a comprehensive overview of our sensor readings. There is our temperature climbing up because this this test we're doing, it is not consistent. Sometimes the CPU will work harder, sometimes it won't, depending on what kind of calculation it's performing. This is this is just the nature of it, of this Prime 95 software. So there we went from 85 to 65 degrees pretty fast. We went back to 4.13 gigahertz. We have Power reporting. So this is, what do we have here? Power reporting deviation. So it's reporting, see, this is our motherboard temperature, various sensors on the motherboard. Oh, this motherboard has some seriously good power delivery system. It doesn't even get hot. Wow, that's good. So, and as expected, our CPU maximum temperature was 83 degrees. Our voltages and some storage device outputs. So this is the gist of how to test if your system is stable, and we can go ahead and what is uh, what I would like to see if all the cores are still under 100% load. They are not. Some of the cores are not under load, and I wonder why that is. Not running. So fatal error. So hardware failure detected. So what this means is that the calculation that this thread was expecting did not uh, complete successfully. So it ran 3 tests successfully, then there was an error on this core. It didn't bring down the system, but nonetheless, this is not a stable system as of right now. So I would have to look uh, into configuring any settings that will stabilize this system. This also could have been because I'm doing all kinds of stuff in parallel while I'm running this test. So it would be a good idea to just probably uh, run one test at a time. If you're running Prime, run Prime. If you're running FurMark, run FurMark, but leave it at one at a time because I will have to investigate exactly what's causing the stress test to fail. So I'm going to go ahead and stop this test at this point. There, good. There it goes. Stop for all workers. And let's also exit out of this thing. FurMark. FurMark is running strong, no artifacts, maximum 61 degrees. So we can go ahead and stop that. So I'll go ahead and close this. close this thing, and I'm going to close the Prime 95, exit. Now, what I would like to try to do, I'm going to leave RyzenMaster running over here, and I'm going to try running Prime 95. Close. This is GPU Z. I'm going to go ahead and close that. All right, and leave RyzenMaster open. And then I'm going to try running Prime 95 again without running anything else and see how that goes. Blend, and I'm going to run for an hour. And see all of these workers from 1 through 32 are running. I'm going to open up the task manager, leave this here, leave this here, and what else would I like to do while it's running this stress test? I'm gonna go ahead and pause the video, and we'll come back and see if the system ran without an issue. So if it runs without an issue now, what it would tell me is that I should have left it running without opening any additional tasks while this is running, to just minimize any possibility of of this program, of the stress test, being interfered with from like other software launching. So if this runs stable for another hour, I would, because I already did stress the CPU before and it was running without a problem. So this would tell me that the system is stable enough, and I'm going to leave it at that. I'm not going to run this test for 8 hours because I already did this when I first got the CPU and it was fine on the AX370 motherboard that I swapped out. So that being said, I'll go ahead and pause the recording now and come back in an hour to check on this thing. Okay, so I left it on for about an hour and came back, and the system was off when I came back. So that tells me that it overheated and shut down to preserve itself. So I'm gonna power it back on and see what happened. Uh, oh, it didn't. I just went to sleep. I thought it was unstable. What happened? I see the problem. Oh, Oh, it did not crash, and it did not shut down, but we have a torture test that failed. So why did it shut down before, or rather, the screen went off? Control panel. Power. Power, 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 power. Here we go. Okay. So we need to not put computer to sleep. Let's not turn off the monitor either. And well, 1, 2, 3, 4, 5 cores. 1, 2, 3, 4, 5, 6 cores. Not exactly cores, but rather threads. 6 threads are not stable. So I'm going to stop this test. I thought it overheated, but it actually did not. It just went to sleep. Okay, so advanced view. Hmm. Let's see what happens here. Let me restart this test real quick. See what happens. So torture test started on 32 threads. We see peak current CPU limits, so we are maxing out our CPU. Okay, so the CPU cannot handle any more current. Temperatures are fine. Clock speeds are fine. Hmm. Hmm. They were failing pretty quickly, the threads. So we'll see what happens. One thing I could mention is that water cooling, an AIO system, is recommended for this CPU that I'm running. I don't think that's the problem. Uh, I'm gonna leave this on for a few minutes and then come back, see if anything fails. It could have failed. Well, we're gonna see if it fails now. Now that I disabled power, the power management of well, the sleep mode basically. So I disabled that, and we're gonna see what happens. Gonna pause the recording. Okay, I'm back after close to an hour, and it appears that we have the same issue here. Now, we had 6 threads. 1, 2, 3, 4, 5, 6. Yeah, 6 threads that failed at some point while I was away, and the rest are still running. So, this system, as of right now, is considered not prime stable. So, there could be several reasons for that, which I'm not going to go into right now because this video was meant to demonstrate the tools that test for stability. Sorry. Um, so, I'm going to stop this test right now. It didn't bring down the system. The system is still fine, but some of the threads failed. What this test does is it already compares the results that were pre-calculated previously and compares it to the new results that this computer, the computer that's being tested, uh, if the results match or not. So the results do not match, but the system is still running and it's still up. So if it cannot pass the tests gracefully, that means it's not prime stable. So it cannot run prime on all cores at 100%. So I have theories, but I do not have an answer of why that behaves this way. So that being said, I'm going to stop this test. Uh, in order for our system to be considered prime stable, what happened to my system should not happen. This system is not prime stable at this point. So the next test. On the note of prime stable, right? The system could be capable of running anything and everything except passing prime. So there's different definitions of stability. Like for example, let's see if there's another utility that I'm going to show, another tool, which is what's that tool that's popular nowadays? Cinebench. Cinebench. Could run Cinebench. I'm going to get the latest version of Cinebench. Cinebench. Where is Cinebench? Download directly. Cinebench right there. Okay. So let's see what happens if we run Cinebench instead of Prime. Although they both uh, load up the CPU, Cinebench is more real world than Prime. Prime is also real world from a sense that it is a real world application that is used for distributed computing project to look for ginormous prime numbers. Uh, you can actually read about more about that, about the GIMPs project. Um, but it is not as real world as Cinebench because Cinebench is the load that Cinebench would would put on the CPU is much more real world because people actually do 3D renderings on computers and they use fast computers and sometimes the computers are overclocked. So if it can run Cinebench for like loop Cinebench for half an hour, that's a good sign of stability, really good sign of stability. So the extract all. Let's see if it runs Cinebench. I wasn't planning on including this tool um, into the lineup, but my videos aren't planned, so why not? So we're going to launch Cinebench. I accept, and we can start multicore. So what I believe that this is doing, it's running for 10 minutes. Oh yeah, this is gonna run for 10 minutes. Let's see how this is looking. 100% load. Memory utilization, as you can see, is different. It's not utilizing all the memory like Prime 95 was. And this is also behaving a little bit differently. Strangely enough, the temperature is lower than on Prime. So even though we are loaded up to the brim in the red, this is running with less heat than Prime. It's generating less heat is what I meant to say. And how is our boost? It's not boosting as far as Prime. It's not going to 4.2 like Prime was. So behaves rather differently. So there's that. My ultimate plan for this system is actually to underclock and undervolt it and run ESXi on it. So I'll have to play it by ear a little bit and see how that will work out. Of course, I'm going to make videos about it. I'm going to pause the recording and come back when it's closer to being finished in about 6 minutes. Alright, so we're almost finished with the Cinebench run. 18 passes. So I think this runs for 20 passes, and so far there has been no problem. And let's check the RyzenMaster. Temperature is under 70 degrees. It's fine. Temperatures are good. No problems with our threads. So yeah, 20 times. This is the last run. Oh, there's our score. 24,018. Let's see what the average score for this CPU is. Okay, so Google. Cinebench R23 Ryzen 3950X. Okay, so single thread, single core. Cinebench. Single core, multi-core. Here we go. 2450. 2418. Within a margin of error. Same score. So this CPU is running as expected without a problem, but it's not prime stable. So I haven't honestly done enough research regarding prime on modern CPUs, on the latest generation CPUs. So things could have changed a little bit, but that would not change the fact that if the CPU cannot run prime, it's not prime stable. So that being said, last utility to test for system stability, we're going to need a flash drive. Flash drives in. We can close this tool, close this browser, I close RyzenMaster, and we'll go back to our downloads. Everything we've downloaded, so FurMark, and we have memtest here. Memtest we can probably use, instead of Rufus, we'll just use the imager that comes with it. And this is our flash drive. Write image to USB, USB image, and let's proceed. Okay. Final warning, the contents of the selected drive will be replaced. Destruction and data loss. Yes. It's possible that if you want to reuse the drive afterwards, it would have to be wiped completely. That means the partition table would have to be wiped, and a new partition would need to be made. Uh, Actually, it wouldn't be partition, it would be partition table. Because it'll make its own. It's writing the image directly, including its whatever the partition table is on the image, I'm assuming. So we can actually check what it does afterwards, after it's finished. CMD. It's going to verify the contents. Perfect. So let's see what happens to our drive now. Disk part, list disk, and yeah, it would have to be repartitioned because this is our flash drive and this is the free space. That means if we simply go to our computer and format it like this, it'll be 249 megabytes. So after I demonstrate the test, I will demonstrate how to get your drive back to normal after you finished running memtest, so you don't have to be stuck with 250 megabyte hard drive. I mean, flash drive. Okay, so we're gonna reboot. And we need to boot from the flash drive. So boot override key on this motherboard, usually F10. Oh, let's see, F12. F12 to boot override, and I didn't press it on time. So we're booting back into Windows. I'm just going to reboot real quick. On this particular motherboard, gotta start hitting F12 earlier. And we can boot from, I believe this memtest86 does support UEFI booting. So let's see right now. Yeah, there it goes. Okay. Okay, so we're going to, we can probably use the mouse here too. Yep. So let's config our system information, and we could just, where is this thing? Start test. So this will run for a while, for a long time. And pretty much for passes, it will at some point end on its own. And after that, you can say that your memory, as configured, is stable if you see no errors on the screen. This test, of course, will depend how long it runs. Will depend on the amount of memory you have, and oh, of course, I'm not going to be running this now because I already ran this on this memory before. So for the last thing in this video, I'm going to show you how to return your flash drive back to normal after imaging this onto it, this mem test. So press escape and test number 2. Test completed. Escape. Press any key to continue. And continue, and we want to exit. I'm gonna boot back into Windows. We want to run command prompt as administrator. Disk part, list disk. Now, here, this is very important. You absolutely must pick the correct disk, which represents your flash drive. It's obvious that the first 5 drives I have from 0 to 4 are bigger than my flash drive because they're over 100 gigabytes at least, and the flash drive is 16 gigabytes, which is reporting 15, but that's okay. So what we want to do is select it. Select disk 5. We have our flash drive selected. Now what we want to do is we want to issue the clean command. This wiped the partition table of the drive, and we can exit from here. And exit from here also. Then we would go to control panel. And we want to go to administrative tools. And from administrative tool, we want to go to computer management. And from here, we have disk management. It's asking me if I want to initialize my drives. I do not at this point because I'm not planning to keep this Windows installation for too long. And when you find your flash drive, it's right here, disk 5. We're going to right click on unallocate it, add new simple volume, next maximum size. You can select that and click next. It's maximum size by default. Assign drive letter, sure, why not? And we are going to, it's up to you if you want NTFS or FAT32, but on such a small drive, I'd prefer to stick to FAT32 because I use it for flashing firmware and BIOSes and all kinds of other stuff that need FAT32. And then we're gonna put a label here, whatever you like, and perform quick format. Finish. And momentarily, there it goes. There it is, FAT32 full capacity drive. There, computer. There it is. Good as new. So this is the end of this video, and uh, I will continue with this making videos with this new computer by tweaking it a little bit more to see if we can get it undervolted and underclocked. And then after I'm satisfied with the result, I will continue with VMware and ESXi installation on this machine. So that's it for now. Thank you very much for watching. I hope this was useful to you. Take care, everybody.